Hello guys, welcome to Digital Learners. Today in this session we are going to see some problems on the bearings, that is related to bearings. So let's start. I'll write the question, that is, in a thrust bearing, the external and internal radii 'of the contact surface are 210 mm and 160 mm respectively. The total axial load is 60 kilonewtons and coefficient of friction is 0.05. The shaft is rotating at 380 rpm. The shaft is rotating at the 380 rpm and the intensity of the pressure is not to exceed 350 kilonewton per meter square. Then calculate. One is power lost in overcoming forces, sorry, coming the friction, and second one is number of collars required for the thrust bearing. So this is the given problem. So now we want to find out the solution for this given problem. So let it write down this solution. Now first we want to write the given data. So given data, given R1 is 210 mm. So contact surface radius is 210 mm, that is 0.21 meters, and similarly R2 is 160 mm. So in terms of meter it is 0.16 meter. So this is the radius of the internal, and this is an internal and this is an external diameters. radius. And next, W. The total axial load is 16 kilonewtons. That is W. Load W is 60 kilonewtons is given that, and we want to convert this into newtons. So 60 into 10 power minus 3 newtons. So in terms of kilonewtons to newtons. And also the coefficient of friction is also given. Coefficient of friction mu, that is 0.05. And next, coefficient of friction, the shaft is rotating about 380 rpm. So speed n is equals to 380 rpm. Intensity of the pressure is not exceed 350 kilonewtons per meters. So the pressure is given that 350 kilonewtons per meter cube. So the radius of internal and external is given, and load is W is given, and uh, mu is coefficient of friction mu is given, and speed P values also are given. So we want to convert this P into in subs of newtons. So we have converted that W into newtons. So 350 into 10 cube Newton per meter cube. Sorry, not this meter cube, this is meter square actually. So meter square. And now we want to find out the power. The first one is given, power lost in the overcoming the friction. So power lost in overcoming the friction. Now let it find out this. We know that for uniform pressure, total friction total frictional torque transmitted T is equals to, that is total friction transmitted T is equals to 2 by 3 into mu into capital W into R1 whole cube minus R2 whole cube by R1 square minus R2 square. So by substituting the all values in this equation, we get the final equation, that is power lost in the overcoming the friction. So 2 by 3 into coefficient of friction mu is 0.05 into W is 60 kilonewtons, that is 60 into 10 cube newtons, and radius R1 is 0.21 cube minus 0.16 cube by 0.21 square minus 0.16 square. So So by substituting all the equations, we get the final equation, that is value of T is 558.37 in terms of Newton meter. So we get the total frictional torque transmission. So now we want to find out that now W. So the value of W is equals to 2 pi n by 60. We know this. So by substituting the values, 2 into pi into value of n is 380 by 60, that is equals to 39.79 is the answer in terms of radians per second. So W in terms of radians per second. So let me find out this. So the power lost in overcoming the friction, power lost P is equals to, we get the value of T into W. So by substituting these two equation values, value of T is, that is from this we have 558.37, 558.37, and W is 39.79. So after calculating these two values, we get that 2221 watts. So this so in terms of kilowatts, power is equals to 22 kilowatts, approximately 22 kilowatts. So we have the find out the power value, that is P value. Now we want to find out that another one, that is the number of collars. So the number of collars used in the, so the number of collars required for the thrust bearing. So we want to find out this second one, that is number of collars required for the thrust bearing. So number of collars required for the thrust bearing. We want to find out this. Let n is equals to number of collars required, and we know that intensity of uniform pressure so the intensity of the uniform pressure, that is P is equals to, in first problem we have the power lost, so that is total frictional torque. Now we have to find out intensity of the uniform pressure. So P is equals to W by Np into R1 square minus R2 square. So by substituting all the values, we get the final equation, that is final value, that is we know that P value also, that is 350 into 10 cube. So power is 350 into 10 cube from the given data is equals to 60 is the 60 into 10 power cube is the W value, and N into pi into R1 square is 0.21 square minus R2 square is 0.16 square. So by take n from this side and this value into this side, so we get the final equation. N is small n is equals to 2.94 is the final answer. That is n is approximately is equals to 3. So number of collars is required for the thrust bearing is 3. So this is the given problem. They were asking the power lost over in the incoming the friction, and we have find out that is power P is equals to power lost P is equals to approximately 22 kilowatts, and next number of collars is required for the thrust bearing, that is small n is equal to approximately 3. So number of collars is required 3, and finally hence we find out that the power lost in overcoming the friction sorry, this is not P, friction F, yeah, friction power lost in the friction P is equals to 20t kilowatts, and second one is number of collars required for thrust bearing, that is n is small n is equals to 3. Thanks for the watching video. For more problems, if you have any doubt on this concepts, and please comment on the below. Thank you.